Number one, the function f of x is undefined when x equals. Okay, so if you want to determine what makes something undefined, a fraction is undefined when the denominator equals 0. So basically what you do is you ignore the numerator. Okay, we completely ignore the top here. And we just take this denominator and set it equal to 0. All right, and then just solve. So here we can see we're going to have to factor. So since we have a trinomial with a leading coefficient is 1, we set up 2 sets of parentheses. And don't forget that equals 0, right? We have to keep it in equation the entire time. And we're going to do our AM method. We're going to find two numbers that add to positive 2 and multiply to negative 8. So positive 4 and negative 2. And since this is an x squared, we put an x here and here. And then we're just going to make our t-chart, and when we solve, we get x equals negative 4 and x equals positive 2. All right, so that is choice 1. All right, so number 2, they just want us to take this and write it in simplest form. All right, so whenever you want to simplify a fraction, all they want you to do is factor the top, factor the bottom, and then cancel off whatever you can. Now, let me start with the top of this fraction. All right, if I were to factor the top, the first thing I'm going to do here is pull out an x. And when I do, that would leave me with, in parentheses, x squared minus 9. Okay, now I want to point out, normally I would factor this further, but I'm looking ahead. Look at the denominator. The denominator says the same thing, but in the opposite order. It says 9 minus x squared. So although I could factor this using dots to x plus 3 times x minus 3, and I could factor this using dots to 3 plus x times 3 minus x, I'm not even going to bother, because remember, if you have two expressions, one on top of a fraction and one on the bottom of the fraction, that have the same expression just written in the reverse order, right? X squared minus 9, and then 9 minus x squared. We can cancel those off, but they create a negative somewhere. So as long as you put a negative 1 somewhere, you can do that. All right, and then right here, negative 1 times x is just negative x. So that would be choice 1. Okay, so number 3, they want us to take this numerator and divide it by this denominator. They say the expression is equivalent to. I mean, you could try to factor the top and then see if anything cancels off on the bottom, but by looking at the answer choices, that's not really going to lead us anywhere. So they're kind of, showing us here we are going to need to do long division, and we'll either wind up with a remainder or we won't. Okay, now if you notice, remember our denominator always goes on the outside of the division bar, right? And the numerator always goes underneath. But if you notice, the exponents go x to the 4th, x to the 3rd, and then x to the 1st, x to the 0. It's missing that x squared term. So what we do is we put a plus 0x squared just as a placeholder so everything lines up when we do the process of long division. All right, let me just move this up to give myself a little room. Okay, so let's go for it. So when we do long division, we want to look at the first term on the outside of the division bar and the first term under the division bar. And you want to say, what do I multiply x by to give me 5x to the 4th? So I need to multiply it by a 5 as well as x cubed. Okay, now let's distribute. 5x cubed times x is 5x to the 4th. And then we need to distribute the 5x cubed to the 7, right? What we put on top gets distributed to both terms here. So 5x cubed times 7 would be 35x cubed. Okay, after we finish distributing, this is where we're going to change our signs. And please remember to circle them, because then you know, oh look, I changed both of them. Okay, so this positive is going to become a negative, and I'm going to circle it to show I changed it. And this positive is going to become a negative, so I'm going to circle it. And not only to show that I changed it, but also so when I combine my like terms, it's apparent which sign I'm using. All right, your first two terms will always cancel out. And then here, right, we're doing 33x cubed minus 35x cubed. Okay, we're using the circled one. So since 33 minus 35 is negative 2, we'll wind up with negative 2x cubed. Okay, now we only have one term down here, but we have two terms out here. So what we do is we bring the next term down, and that way we have the same number of terms down here as we do up here. And we just keep repeating the process. All right, so look at the first term outside the division bar and the first term of the expression we were just left with. You want to say to yourself, what do I multiply x by to give me negative 2x cubed? So you're going to multiply by negative 2 as well as an x squared. So that's what we're going to put up here, negative 2x squared. And then we can distribute. So negative 2x squared times x is negative 2x cubed. And negative 2x squared times 7 is negative 14x squared. Okay, and then again, we change the sign. So I'm going to change this negative to a positive and circle it. And I'm going to change this negative to a positive and circle it. Okay, always remember to circle it. All right, so our first two terms, when we combine like terms, cancel off, which should always happen, right? If it doesn't, it means we got to go back and figure out where we made our mistake. And then 0x squared plus 14x squared would be 14x squared. And again, we bring down this next term. All right, we got to just keep going, right? Keep repeating this process. So you say to yourself, what do I multiply x by to give me 14x squared? So 14x. So I'm going to put a positive 14x. And don't forget your signs, right? Don't just write 14x. You have to have a plus sign here. Okay, so then when we distribute, 14x times x would be 14x squared. And then 14x times 7 would be 98x. So plus 98x. Okay, when you finish distributing, now change your signs. So this becomes a negative, circle. This becomes a negative, and circle. All right, so when we combine our like terms, the first two terms cancel off. And since 96 minus 98, right? Don't forget to use that circle sign. 96 minus 98 is negative 2. We're going to have negative 2x. Right? Always keep that variable. And then we'll bring down our last term. So since we know we're bringing down the last term, this is going to be the last step of it. And we may have a remainder, or we may not. So let's see. All right, so last time, what can we multiply x by to give us negative 2x? So negative 2. All right, so when we distribute, negative 2 times x is negative 2x. And negative 2 times 7 is negative 14. So now when we change our signs, right, this becomes a plus and circle, and this becomes a plus and circle, and you could see we are going to have a remainder. The first two terms do cancel off, but negative 16 plus 14 is negative 2. And how we write a remainder, right, please don't just do this. Don't put negative 2 over what we're dividing by, x plus 7. Okay, that negative needs to come down over here, right? It needs to separate our quotient, what we were dividing by, what our answer when we were dividing, from the remainder. So this minus sign needs to come right down here. And actually, I know this is a little nitpicky, but this fraction right here should move down a little. Like this minus sign should be in line with that fraction bar. So actually, believe it or not, I'm going to make that happen. I like my work to, be 100% correct. Okay, so a remainder of negative 2, the negative goes in front of the fraction bar, and then the 2 goes on top. And on the bottom, in the denominator of the fraction, we put what it was we were dividing by. Okay, I'm just going to scroll back up because we got to figure out which answer choice that was. And it looks like all the answers on page 1 are choice 1. Okay, that matches up with choice 1. Okay, number 4, it's actually phrased the same way number 3 was. They want to know which expression is equivalent to this. So, I mean, you have to decide, am I trying to factor the top, factor the bottom, and see what cancels? That could be the case. Or are we trying to do long division here? Now, I mean, we don't really know how to factor this numerator here, right? So I'm thinking, let's try out long division. And, you know, if you really run into a bind and you're not sure what to do, remember, whenever they want to know which is equivalent and it's a multiple choice, you can always plug the question in your calculator and hit enter, plug the answer choices in one by one and hit enter, and just see what matches up. Okay, but I'm going to use, I don't want to do the calculator cheat method unless I'm like all out of options. And also remember, for the multiple choice, it did say you have to show work. So we're going to do it through long division. Now, if you notice underneath my division bar, right, the original expression, this went from x to the third power all the way down to no x's, right, x to the 0 power. So we were missing the x squared term and the x to the first term. So we have to put in a placeholder, plus 0x squared and plus 0x. So that way we have x to the third, x to the second, x to the first, and then no x's. All right, so let's do it. Long division. Okay, so you want to look at the first term on the outside of the division bar and the first term underneath here. And you want to say, what do I multiply x by to give me x cubed? So we're going to do that by x squared. And then let's distribute. X squared times x would be x cubed. And x squared times negative 2 would be negative 2x squared. Okay, so whatever you put on the top of your division bar up here has to distribute to both terms outside the division bar. And if you have more than 2 terms, you'd have to distribute it to everything outside the division bar. Okay, so once we finish that, we know we have to change our signs. So I'm going to change this to a negative and circle it, and this to a positive and circle it. Okay, so here we're doing subtraction, and here we're doing addition. So our first 2 terms we could see cancel off, which should always happen. And then 0x squared plus 2x squared would be positive 2x squared. And since we have 2 terms on the outside of the division bar and only 1 down here, we need to bring down the next term. That way we also have 2 terms down here. All right, let's start this process again. So you want to say to yourself, what do I multiply x by to give me 2x squared? Well, we'd have to multiply that by 2x. So I'm going to put a plus 2x on the top. Okay, don't forget your plus sign. All right, so 2x times x is 2x squared. And 2x times negative 2 would be negative 4x. And then when we change our signs, this becomes a minus sign and we circle it. This becomes a plus sign and we circle it. So always circle your signs. Don't skip that part. All right, so your first 2 terms cancel. And then 0x plus 4x is 4x. And let's bring down the next term. And since this is the last term we're bringing down, we know we're going to be at the last step of long division. Okay, so, I mean, we could see right away. I'm looking x squared plus 2x. This is the only one that even says that, so choice 2 has to be the answer. But let's just finish it out because we, could have made a mistake. All right, so we say, what do we multiply x by to give us 4x, positive 4? So look, that's still matching up. So far, so good. Okay, so 4 times x is 4x. Then we also have to distribute the 4 to the negative 2. So 4 times negative 2 is negative 8. And then when we switch our signs, this becomes a minus, this becomes a plus. We wind up with the first 2 terms canceling out, and since negative 2 plus 8 is positive 6, we wind up with a remainder of 6. Now, since it's positive, we put a plus sign here. And then we just take the number itself, so the 6, and we put it over what we were dividing by, which is x minus 2. And that does match up with choice 2. Okay, so number 5, we're given f of x and g of x, and they want us to state the quotient and the remainder of f of x divided by g of x. And they want us to put it in this form. So they're just saying the quotient, which is q of x, and the remainder, which would be r of x over what we're dividing by, which is g of x. So they're just telling us here we're going to have a remainder. Okay, so let's do it. Let's take f of x and divide it by g of x. So g of x goes on the outside of the division bar. and then f of x goes underneath the division bar. And this time we were given an x to the third, x to the second, x to the first, and then no x's, so we didn't have to insert any terms. Okay, so let's do it. We've done this a few times already in the video, so let's do the same thing. All right, so we want to look and say, what do we multiply x by to give us 3x cubed? So it's going to be 3x squared. Put that on top here, and then we're going to distribute that 3x squared to both terms on the outside of the division bar. So 3x squared times x is 3x cubed, and 3x squared times negative 4 would be negative 12x squared. Okay, and then what we're going to do is we're going to change our sign. So we're going to make this a minus sign and circle it, and we're going to make this a plus sign and circle it. We circle it to show we changed it, and we also circle it so that we know which sign we're going to be using, because sometimes you'll see more than one sign there. All right, so these first two terms cancel, and since negative 4 plus 12 is positive 8, this will combine to give us positive 8x squared. And let's bring down the plus 2x. Okay, let's start the process again. So what do we multiply x by to give us 8x squared? 8x. So on top, we're going to put plus 8x. If you're multiplying by positive, right, we put a plus sign there. Okay, so let's distribute. 8x times x is 8x squared. And 8x times negative 4 would be negative 32x. Okay, so we're going to change our sign. So this becomes a minus and circle it. This becomes a plus and circle it. And I would wait to change your signs until you're done distributing, because I find when people don't, sometimes we only change one of them and not both of them. So I would just wait. Okay, so the first two terms cancel. And 2x plus 32x would be positive 34x. And now, since we're bringing down the last term, this is the last time we're going to have to do this process. Okay, so x times what gives us 34x? Positive 34. And when we distribute, 34 times x is 34x. And then 34 times 4 would be negative 136. Okay, so we're going to change our sign. So this becomes a minus, circle. This becomes a plus, circle. And this time we have a big remainder. That's okay. The first two terms cancel, and negative 1 plus 136 is positive 135. So that would be our remainder. So we know we write our remainder. If it's a positive, we put a plus sign, and we take whatever number we see in the remainder, which is 135, and we put that over what we're dividing by, which is x minus 4. Okay, so let me box this off. This is the answer to the first part, right? The first part says to state the quotient and remainder. So here's our quotient, and here's the remainder in this form, right? Q of x is here, and then they want us to take r of x, the remainder, and put it over g of x, what we were dividing by. So that looks good. Now it wants to know, is x equals 4 a root of f of x? Another word for root is 0 or solution. So if x equals 4 is a root of f of x, wouldn't that mean that x minus 4 is a factor? Now, we know that x minus 4 is not a factor because we have a remainder. So since we have a remainder, x equals 4 is not a root, okay? If x minus 4 divided evenly into this expression and there was no remainder, then x equals 4 would be a root. But since we have a remainder, x equals 4 is not a root of f of x. Okay, and since it says explain your answer, you have to put it into words. So I said x equals 4 is not a root of f of x because x minus 4 does not divide evenly into f of x. Okay, so given r of x find the value of r of 2. Okay, it's okay to use your calculator for this question. Like if they want you to find the value of r of 2, in your calculator you could type in 2 store x, right? And then type in what r of x is equal to, and your calculator will automatically substitute in 2 for you. And when you do, you get -6. All right, so you can just write out, I mean, if you do this in your calculator, you don't really have to show much work. You could just write r of 2 equals -6. And that really is enough work because you are allowed to do that in your calculator. If you do want to show all the work, you can write this out. You could write r of 2 equals, and you could show that you're substituting 2 in parentheses for each x, and then you get -6. But this is not necessary. Honestly, the only thing you really need to put on your paper is this right here. R of 2 equals -6. Okay, now, what does your answer tell you about x minus 2 as, it's kind of cut off, but a factor of r of x? Explain. Well, what this means is when we plug 2 into this function, if x minus 2 were to be a factor, then r of 2 would be a 0. This would be equal to 0. So since this is not equal to 0, x minus 2 is not a factor. And because they say explain, you have to put that into words. Okay, so I just said x minus 2 is not a factor of r of x because r of 2 does not equal 0. Okay, and I'm just going to circle in red. This and this is really the only thing that you need to put on your paper to get full credit. Okay? Okay, so in number 7, the first thing they want us to do is they want us to evaluate h of -8. So really, all you're going to do is substitute each x with a -8. Now, because you're allowed technology on your tests and on the regions, you can really do this in your calculator. It's really a calculator question. So in your calculator, you could just type in -8 store x, and then hit enter. And then if you type in this expression right here and hit enter, your calculator is going to substitute in -8 wherever it sees an x. So when we do that, we could see it's equal to 0. So basically, h of -8 is equal to 0. That's all you have to put. Now it says to explain what your answer tells you about x plus 8 as a factor of h of x. Well, if h of -8 equals 0, that means that -8 is a 0 of this function. So if -8 is a 0 of this function, then it means that x plus 8 is a factor of h of x. Okay, and that's all you have to write. X plus 8 is a factor of h of x because of this reason. H of -8 equals 0. What that means is -8 is a 0 of the function. Okay, so in the next part it says to algebraically find the remaining zeros of h of x. Now, if you tried to take this and set it equal to 0, what you would find is if you tried to do grouping to solve this, you wouldn't wind up with the same thing in the parentheses. You would kind of run into a dead end. So we're going to have to come up with another technique. So instead of setting that equal to 0, well, let's think about it. If we know that x plus 8 is a factor of h of x, doesn't that mean that x plus 8 would divide evenly into that expression? So let's do long division. Let's take what h of x is equal to and divide it by x plus 8. Okay, so here we go. So we want to look at our first term outside the division bar and the first term underneath and say, what do we multiply x by to give us 6x cubed? So we're going to multiply it by 6x squared. And then when we distribute, 6x squared times x is 6x cubed. And 6x squared times 8 would be 48x squared. All right, so now to show we're subtracting, we change our signs in circle. So we'll change this to a minus in circle and change this to a minus in circle. So our first two terms cancel off. And since 47 minus 48 is -1, we're going to bring down a -1x squared. Or you could just write -x squared. That's fine. Either way. Okay, so now since we have two terms on the outside of the division bar, we need two terms down here. Now, I only see one. So what we do is we bring down the next term. And let's start the process again. All right, so what do we multiply x by to give us -1x squared? So negative 1x, which I'm just going to write as negative x. And now let's distribute this negative x to both terms on the outside of the division bar. So negative x times x is negative x squared. I mean, if you want to put the 1 in here just so that it lines up with that one, you can, but you don't need it. And then negative x times 8 would be negative 8x. And then we're going to change our signs, so make this an addition and circle, and make this an addition and circle. So our first two terms cancel off, and negative 23 plus 8 would be negative 15. So because we have an x on it, we're going to bring down the negative 15x. All right, we're going to bring down our last term here, and that's when we know we only have one more time of, this process because we have nothing left to bring down after this. Okay, so what do we multiply x by to give us negative 15x? So negative 15. And when we distribute this negative 15 to both terms out here and subtract, we should not wind up with a remainder. We know we're not going to have a remainder because if x plus 8 is a factor of h of x, it should divide evenly into it. All right, so let's do it. So negative 15 times x is negative 15x. And then negative 15 times 8 is negative 120. And when we change our signs, so this becomes a positive when we circle, this becomes a positive when we circle, everything cancels. So we know we're on the right track. Now, it says here that they want us to algebraically find the remaining zeros. So we already know one of them is negative 8. They just want us to use this quotient to help us find the remaining zeros. Okay, so we're going to use this quotient right here. We know that x plus 8 is one factor, and this is another factor. So what we're going to do is we're going to set the other factor equal to 0. And we're just going to factor this and make a t-chart. All right, well, we have a trinomial, right? And there's no greatest common factor to factor out. So since the leading coefficient is something other than 1, we know we're going to have to do the rainbow. All right, so we're going to multiply 6 times negative 15, and that'll be our rainbow number. And we are going to have to find two numbers that multiply to negative 90 and add to, there's really a negative, here, we can put it in if you want, add to negative 1. Okay, so negative 10, positive 9, right? But keep in mind, what we want to do is we want to bring down this first term, bring down the last term, and then we're going to put those two numbers right in the middle with an x attached to them. All right, so let's do it. We're going to bring down our first term. Notice I'm leaving myself space. We're going to bring down the last term, as well as the equal 0. And we said the two numbers that multiply to negative 90 and add to negative 1 would be negative 10 and positive 9. And it does not matter what order you write those in. Like if you want to put the positive 9 first and then the negative 10, that's okay. Or vice versa, as long as you put an x on them. Because if this middle term has an x, we need it on these. And then we could just do grouping. So when I group together the first two terms, I could pull out a 3x, which leaves me with 2x plus 3. And when I group together the next two terms, I can factor out a negative 5, which is also going to leave me with positive 2x and a positive 3. Okay, so then I'm going to group the 3x minus 5 as my first factor, or it could be your second, wherever you want to put it. And I'm going to bring down the 2x plus 3 as my second factor. And we're going to make a t-chart and solve. Now, I know a lot of you can look at this and just say, all right, I don't have to show work. I'm going to wind up with positive 5 thirds. And I'm going to wind up with negative 3 over 2. But if you can't visually see that, that's okay, no big deal. Just set each of these equal to 0. And, solve. Okay, so over here I would have to add 5 to both sides of the equation. So if you want to write plus 5, show you're doing that, you can. Or, think about it, if we move a negative 5 to this side of the equation, doesn't it just become positive 5? So I'm going to wind up with 3x equals 5. And then to get the x by itself, don't I have to divide by 3? So if you want to show divided by 3, you can. The only reason I'm not is because I'm running out of room. But if I divide both sides by 3, right, the 3's on this side would cancel, so I'd bring down the x. And on the right side, 5 divided by 3 is just 5 over 3, 5/3. Right, that's kind of smushed in there. So I'm going to rewrite it over here. 5/3. I'm going to use curly brackets. I know that's going to be my bigger solution, so I'm going to write that second. Okay, now on this side, if I wanted to solve this, I would subtract 3 from both sides of the equation. So if I did, right, if I took a positive 3 from the left and subtracted it, or just moved it to the right, it'd become a negative 3. So I'll have 2x equals negative 3. And then to get rid of this 2, I have to divide both sides by 2. So when I do, on the left, I'll be left with x. And over here, 3 divided by 2, I'm sorry, negative 3 divided by 2 is just negative 3 over 2. Which again, that's kind of smushed in there, hard to see. So I'm going to rewrite it over here as negative 3 over 2. Okay, and those are the remaining zeros. So we know that negative 8 was one of our zeros, and these are the 2 that remain. All right, number 8. So we're given P of x, and they want to know which statement is true. Now, these first 2 statements, I mean, honestly, you can just disregard. I mean, they're saying that P of negative 1 equals 2. And although that is true, if something is equal to 2, that doesn't tell us anything about a factor. In order for something to be a factor, we need it to be equal to 0, okay? So again, if you store negative 1 in your calculator's x and substitute it into this function, although it does equal 2, that does not help us with determining a factor. Okay, now if we look over here, these both say P of 1 equals 0, which is true. If you store x as 1 in your calculator and plug in what P of x is equal to, it does equal 0, so this is true. Now, if positive 1 is a 0 of the function, doesn't that mean that x minus 1 is a factor, right? The factor has the opposite sign, so choice 4 would be the answer. Okay, number 9. So they give us f of x, and it says then f of 1/2, well, it's either going to equal 0 or does not equal 0. So you could check that out in your calculator if you want. Okay, so if you stored x as 1/2 in your calculator and then plugged in what f of x is equal to, it is equal to 0, so it equals 0. Okay, so choice 3 and choice 4 are out. Those ones say does not equal 0. So then we want to know, is 2x plus 1 a factor of f of x, or is 2x minus 1 a factor of f of x? Well, here's the deal. You really could do this without showing any work. If positive 1/2 is a 0 of f of x, wouldn't the factor have to have a negative sign? So that being said, choice 2 would have to be the answer, right? The factor has the opposite sign of a 0. But even if you don't see that, let's just factor this, and we'll see that we do have a factor of 2x minus 1. All right, so I just rewrote over here what f of x is equal to, and let's do grouping. So out of the first 2 terms, I could pull out an x cubed, which will leave me with 2x minus 1. And out of the last 2 terms, I could pull out a negative 8, which will leave me with 2x minus 1. So, I mean, you could clearly see right here, 2x minus 1 is going to be one of our factors, because when we group together the x cubed minus 8 and rewrite this common binomial, we could see 2x minus 1 is one of the factors. So that's it. That's all you have to do. So choice 2 would be the answer. Okay, so number 10, they want to know what is the remainder when f of x is divided by x plus 2. So if they're giving us a factor of x plus 2, we're concerned at what's going on at negative 2. We want to know, I mean, we could write this out here. We want to know what's the value of f of negative 2. Okay, so go to where negative 2 is on the x-axis and follow it down to the function, and we could see f of negative 2 is equal to, right here, negative 6. So choice 3. Okay, so we have to write true or false on number 11 for each of these statements. Okay, so we're using this graph. Let's see. there is one relative maximum and one relative minimum. All right, well, that's true. Okay, we have a relative max up here and a relative min right there. So there is one of each. So that is going to be true. All right, letter B. There are two intervals where the function is decreasing. Decreasing means it's going down. So from here to here, it's going up. So that's increasing. From here to here, it's going down. So that's decreasing. And from here to here, it's going up. So that's increasing. So there's actually only one interval where it's decreasing, where it's going down from here to here. So that's going to be false. There's not two intervals. There's only one. Okay, so the next one, the degree of the polynomial is odd. Okay, well, remember for that, look at the left, it's going down. Look at the right, it's pointing up. If one side of the graph is pointing down and the other side is pointing up, that is going to be an odd degree function. It's only an even degree if both arrows are pointing up or if both arrows are pointing down. So this right here is a true statement. It is odd. We have one side down, one side up. Okay, opening in different directions. Okay, letter D. There is a positive leading coefficient. Well, the only thing we're concerned with is what's going on the right-hand side. If you look at the right, see how that says up? If it's up on the right, it's a positive leading coefficient. If it were to be down on the right, it'd be a negative leading coefficient. So since they say positive, this is a true statement. All right, letter E. When f of x is divided by x minus 3, the remainder is 0. Okay, if we're dividing by x minus 3, we want to go to positive 3 on the x-axis. And they're saying the remainder is 0. What that means is the function would be 0 at positive 3. That's not true. The function is going to be somewhere all the way up here. So that is a false statement. Now, I just want to point out, if they had said when f of x is divided by x plus 3, if we wanted to divide by x plus 3, that's when you would go to negative 3 on the x-axis, and the function there would be equal to 0. But when dividing by x minus 3, we have to go to positive 3, the opposite sign on the x-axis, and the function does not have a y value of 0. Okay, letter F. When f of x is divided by x, now when you're dividing by x, isn't x the same thing as x minus 0 or x plus 0? So we're concerned with going to 0 along the x-axis. So if you go to 0 and follow the function down, you could see the y value there is negative 6. So if we divide by x, the remainder should be negative 6. And that's what this says. When f of x is divided by x, the remainder is negative 6. Okay, so that's true. You're just looking for the y value at that point. All right, letter G deals with end behavior. It says, as x approaches negative infinity, so as we look on the left, here's the left, it says the word down. So if it says the word down, this should say negative infinity, which it does. Okay, as x approaches positive infinity, which means as we're going to the right. So here's the right. See how the arrow is pointing up? That means our function should be approaching positive infinity, which it does say here, positive infinity. So I'm going to write true on the line. Now, technically, there's a mistake in this question. So if you wrote false, I'd have to give you credit, because if you wrote this out as your work, you wouldn't get full credit. This says p of x. What should it say? It should say, look, up here, f of x. This function's f of x, not p of x. So technically, that's a typo. That's a mistake. So if you wrote false, I would have to give you credit for that, too. Okay, and then letter H. A possible factorization of f of x is x minus 3, x minus 1, and x plus 2. Now, if these are the factors, these should have the opposite signs of the zeros. So if we have a 0 at x minus 3, the factor would have to be x plus 3. So this is false. If we have a 0 at x equals negative 1, the factor would have to be x plus 1. And if we have a 0 at x equals positive 2, the factor would have to be x minus 2. So these actually have the opposite signs of what the factorization should be. So this would be false. Okay, so number 12, which binomial is not a factor of the expression? Now, I know some of you may have tried to factor this, right, by grouping, but when you do the parentheses, do not match up. So we need to come up with a plan B. I mean, honestly, what I would do is I would just go to y equals in my calculator and plug this in. And we know that wherever there's a 0, the factor should have the opposite sign. Okay, so you go to y equals, plug in this expression, and you could either look at the graph or look at the table of values. Either way, you'll see that at -2, at +6, and at +7, right? -2, the y value is 0. +6, the y value is 0. And +7, the y value is 0. Okay? So these are our zeros. -2, +6, +7. So your factors would be x plus 2, which is choice 1, x minus 6, which is choice 3, and x minus 7, which is choice 4. Okay, choice 2 is the only one that is not there. It's not a factor. Okay, so which description could represent the graph of f of x if we're given this and a is an integer? All right, well, there's a few different ways we can go about this. And a really easy way is to just pick any integer and substitute it in for a. So for example, let's just plug in 1 for a, okay? In your calculator, you could go to y equals and substitute this in and just replace the a with any integer. Okay, so I replaced the a with 1. See where the a's are right here? Replace those with 1s. Okay, so now what I'm going to do is I'm going to hit graph. And the graph is a little hard to see. To me, it looks like it's going up, down, and back up. And it looks like it has 1, 2, 3 x-intercepts. If you're not sure, you can always hit zoom. And I'm going to just zoom in, choice 2. Okay, choice 2. And if I hit enter to zoom in, we could see there are 1, 2, 3 x-intercepts. Okay, so we could automatically rule out choice 3 and 4 because they say 4 x-intercepts. So it's not going to be those. And then if we look at the end behavior, we could see on the left, the graph is going down, and on the right, the graph is going up, which is what choice 2 says, right? As we go to the left, the graph is heading towards negative infinity, so going down. And as we go to the right, the graph is heading up towards positive infinity. So choice 2 would be the answer. The other way to think about this is, I mean, if you understand that, you could stay with that. But if you think about it logically, ready? Isn't 4x squared times x 4x cubed? So we have, it doesn't even matter what's going on after that. This lets us know we have a third degree function. And since this is a positive 4, we have a positive leading coefficient. So our function is going to go up, down, up. Okay, it's going to end up going up because we have a positive leading coefficient. And since it's cubic, right, it's going to open in opposite directions. Third degree, up, down, up. Now, it can't have 4 x-intercepts because it only has 3 directions, right? Up, down, up. So it would have 1, 2, 3 x-intercepts. So choice 2 would be the answer. Okay, so number 14, they want us to sketch a possible function of m of x given all of these conditions here. All right, so let's take a look at what they give us. Okay, so I'm going to start with this in the front here. This tells us, see this negative? This tells us that we have a negative leading coefficient. So we know that our graph is going to end off coming down, right? So on the right side, it's going to be heading down. And we also know that we have zeros at x equals negative b, right? If we have a factor at x plus b, wouldn't the 0 be x equals negative b? So we have zeros at x equals negative b, x equals negative c, and x equals positive d. So it's at the opposite signs here. Okay, so let me start here. At d, at positive d, we can put a little mark. Okay, our graph is going to go through the x-axis at positive d. Now, it's also going to go through at negative b and negative c. So you could put a negative b and a negative c on the negative portion of the x-axis. But this is important. It says b is greater than c. So if b is greater than c, it's going to be further to the right on the number line. So maybe I'll put b right here. Actually, negative b, right? And then negative c, I'll put to the left of it, because b is greater than c. Okay, so we just need to make a graph that ends off heading down. And it's not, notice there's no squares. It's not bouncing off. It's a third degree function, right? X times x times x is x cubed. So it's going to have 3 different directions. So I'm actually, since I have this arrow coming down already, I'm going to start over here. And have it go. And there's my graph. Now, I'm just going to label it m of x. If you want to write the whole thing, you can. But if you want to just stick with m of x, as long as you label it and put your arrows and label your intercepts, then you're all set. Okay, so in 15, we're given a rational equation, a fractional equation. Now, I like to first look at the denominators and say, if anything can be factored, let's go ahead and do that, because that's going to help us find our common denominator. And we could clearly see this last denominator here can be factored to x plus 3 and x minus 4. Okay, we just have to come up with 2 numbers that multiply to negative 12. So positive 3 and negative 4, and at the same time add to negative 1. So here we go, positive 3, and let me make it a little better, negative 4. Okay, now, if we look at our other denominators, this says x plus 3, which we have right there. This says 4 minus x. That's different than x minus 4, because here our x is positive and our 4 is negative, whereas over here our x is negative and the 4 is positive. But remember, you're allowed to switch the order of this. Here, I'll do this in a different color. We could switch the order of this to say x minus 4, but technically what you're doing when you're switching the order is, aren't I now making the x positive when it used to be negative? And aren't I making the 4 negative when it used to be positive? So to compensate for like pulling out a negative, I'm going to change the sign that's in front of that fraction. So this is going to become a plus sign. All right, so let me rewrite this just so we could see a little better. It looks a little messy. Okay, so I just rewrote this with the plus sign and this as x minus 4, and with this denominator in factored form. Okay, so now if we look at all of our denominators, we could see this right here is going to be our common denominator, x plus 3 times x minus 4. Our first fraction has the x plus 3, but it's missing the x minus 4 that our other denominators have, so no big deal, let's just put it there. But whatever you put in the denominator to keep the fraction equivalent, you have to also put that in the numerator. All right, now our second fraction has the x minus 4, but it's missing the x plus 3 that other fractions have. So again, same thing, we could put it there, as long as we also put it in the numerator. All right, and then our last fraction has it all, right? It has the x plus 3 and the x minus 4. So we don't have to put anything on the top because we're not putting anything on the bottom. So now since they all say the same thing, we could technically just cross off these denominators, right? And what we're solving is what we see here in the numerators. Okay, I like to rewrite everything exactly like I see it, parentheses and all, because a lot of times if you try to distribute as you go, things are forgotten, especially if this right here is a minus sign. Okay, so let's keep solving. So we get 2x minus 8 plus 3x plus 9 and then I'll bring down the equals 2x minus 2. And I just want to point out, I know if you have a second degree equation like x squared or a third degree equation x cubed, you try to get one side of the equation set equal to 0. That is not the case when you're solving a first degree equation where your biggest exponent is a 1. All right, after we finish combining like terms, which I'm going to do right now, right? 2x plus 3x is 5x. And negative 8 plus 9 is positive 1. Okay, so with a first degree equation, our goal is to get all of the terms that contain the variables, right, to one side of the equation, and the numbers to the other side of the equation. All right, so I'm going to first move my variables. We have a 5x and a 2x. Since 5x is bigger, I'm going to keep this where it is. I'm just going to subtract 2x from both sides of the equation. So that leaves me with 3x plus 1 equals negative 2. Okay, now I'm not going to get this side of the equation set equal to 0. I'm going to move my numbers over to that side. So I'm going to subtract 1 from both sides, leaving me with 3x equals negative 3. And when I divide both sides by 3, I get x equals negative 1. Okay, so now sometimes you have to cross off a solution because it's an extraneous root, meaning that you solved everything correctly, but this root would cause one of the denominators to equal 0, or more than one of the denominators to equal 0, which would create an undefined fraction, so it would mean we can't have it. So if you think about negative 1, if we substitute it into this denominator, negative 1 plus 3 is not 0, so that's okay. If we substitute the negative 1 into this denominator, 4 minus negative 1 is also not 0, so that's okay. And if we take negative 1 and plug it in here, actually it's almost easier to look at it in factored form. So if we plug in negative 1 here, negative 1 plus 3 is not 0. Or if we plug in negative 1 here, negative 1 minus 4 is not 0. So since negative 1 doesn't cause any of these denominators to equal 0, we can have it. So this is our answer. And I always think it's a really good idea to just double check. So I'm gonna double check this in my calculator. Okay, so this is how I go about doing it. If I wanna see if negative 1 is a solution, the first thing I'm gonna do is store x as negative 1 in my calculator. So I type in, sorry, this is like very blurry. I type in negative 1, store x, enter. Okay, so if this is the solution, what that means is if I plug in negative 1 to the left side of the equation, I should get the same exact value as when I plug in negative 1 to the right side of the equation. So always type in the original equation. So what I did here, sorry, again, I don't know why this is so blurry. Okay, I typed in the left side of the equation, the original, exactly like I saw, and hit enter, and it gave me 2/5. So basically, if you substitute negative 1 for these x's, the left side of the equation equals 2/5. Now I also typed in, let me just scroll down because I did this already. I also typed in the right side of the equation. See how this says the same as that? Okay, the original equation. And when I hit enter, it also gave me 2/5. Okay, so what that means is, since I got the same answer here and here, the left side of the equation is equal to the right side of the equation when x equals 1. So our work checks out. Okay, number 16, I mean, it is multiple choice, so if you were on a test, you could just take these answer choices, right, and substitute them in for x, store them as x in your calculator, and see which ones check out. Because this is a review sheet, any classwork, any homework, we actually want to do out the problems, just to really make sure that we know how to do them. Okay, so the first thing we want to do is we want to find a common denominator. Now, both of these denominators say x plus 3. This one just says x, and there's nothing you could multiply an x by to get it to say x plus 3, right? So our common denominator is actually going to include the x as well as the x plus 3. So basically, we're going to multiply this denominator by x plus 3, which we'll also have to do on the numerator, and we're going to multiply both of these denominators by x. That way, all three denominators will have an x as well as an x plus 3. And one thing I want to point out, one thing you're not allowed to do. Please don't think you could just do, plus 3 and plus 3. Okay, you are not allowed to add a number to the top and bottom of a fraction because that changes the value of the fraction. You're only allowed to multiply. So let's get rid of this. This is no good. Okay, so as we said before, we're going to multiply the denominator of the first fraction by x plus 3. And whatever we put in the denominator, we also have to put in our numerator. Whereas we're going to multiply the top and bottom of these fractions by x. Okay, so now if we look, right, whatever we put on the bottom, we have to put on the top. Now if we look, all of our denominators have an x and an x plus 3. X plus 3, x plus 3. So once they're the same, we could just take them and cross them right off. And we are going to solve what we're left with here in the numerator. And I'm going to ask you to please, rewrite exactly what you see and then start to distribute. So I'm going to rewrite exactly what I see here. All right, so let's distribute. So that'll give us 2x plus 6. And then negative 3x times x would be negative 3x squared. And then x times x is x squared. Okay, now there's really no like terms to combine on this side of the equation. So because we have a square, we want to take everything and move it to one side of the equation, either everything to the left or everything to the right. Now in this case, I'm actually, even though it's more to move, I'm going to move everything to the right-hand side of the equation because see how the leading coefficient, right? Wouldn't this be the term with the biggest exponent? That's negative. I don't want a negative. So what I'm going to do instead is I'm going to actually, I'll show I'm doing it. You don't have to show this. You could just move it if you want, but I'm going to add the 3x squared to both sides. And to get rid of these two terms, I'm going to have to subtract the 2x and subtract the 6. So minus 2x and minus 6. Okay, so what happens on the left? Everything cancels. So I have 0 equals. And then on the right, 1x squared plus 3x squared is 4x squared. And then I'm just going to bring everything else down. Now I'm looking ahead here. See how everything on the right-hand side is even? You could factor out a 2, but then you have to keep bringing down the 2. Why don't we just divide both sides of the equation by 2 and just get rid of it altogether? Okay, so 0 divided by 2 is 0. And then I'm going to divide each one of these terms in the trinomial by 2. So this will become a 2, a negative 1, and a negative 3. Okay, so again, 4x squared divided by 2 is 2x squared. Negative 2x divided by 2 is negative 1x. I'm just going to write negative x. And then negative 6 divided by 2 would be negative 3. And all we have to do now is just factor, t-chart, and solve. Okay, now since the leading coefficient, right here, is not a 1, that lets us know we're going to have to do the rainbow. Now when we do the rainbow, we know we bring down the first term. I'm going to leave a big space and bring down the last term. And we make a rainbow from the first number to the last number. So 2 times negative 3 is negative 6. So we want to come up with two numbers that multiply to negative 6 and that add to, this is really a negative 1 in here. All right, so positive 2 and negative 3. You can put them in whatever order you want. So I'm going to write positive 2. And don't forget to put an x on it, because see how this has an x? And then negative 3 with an x. Okay, now we can get into our grouping. So I'm going to group together the first two terms. Don't forget that 0 equals, right? You have to keep it in equation the whole way through. This equal sign should be in every single step, not just some of them. So to the first two terms, I could pull out a 2x, which will leave me with x plus 1. And out of the last two terms, we could pull out a negative 3, which is also going to leave us with x plus 1. All right, so let's group together what's in front of the common factor of x plus 1. Let's group together the 2x minus 3. And again, don't forget the 0 equals. So our first factor is 2x minus 3. And then we're going to rewrite the x plus 1 just once. Okay, and from this point, we can make a t-chart and finish solving. All right, so I'm going to start with the right side of the table, the right side of the t-chart. So over here, we're going to wind up with x equals negative 1. And on the left side, if you could look at this and say we're going to wind up with x equals positive 3 over 2, go for it. If not, just take this factor and set it equal to 0 and solve. Okay, so to solve, we would first add 3 to both sides of the equation, leaving us with 2x equals 3. And then to get the x by itself, we would divide by 2, leaving us, I guess I'll write it over here, with x equals 3 halves, 3 over 2, or 1.5 if you prefer. Okay, now we need to look back and say, let me just move this up a little. Can I fit it? You know what? We'll look at this. Look at what's in black. There's our original equation. If I were to substitute in -1, or if I were to substitute in 3/2 to either of these original denominators, so x plus 3, or x plus 3, would it create an undefined fraction? No, neither one of these would. In order to have an undefined fraction, we would need a 0, which means if I replace this with a 0, it would be undefined. Or if I replaced either one of these with -3s, right? -3 plus 3 is 0, it would be undefined. So since neither one of these answers says 0 or -3, well, we can use them both. Okay, so there we go. So let's see. +3/2 and -1 is choice 4, right here. All right, and finally on to the very last one. So again, we're solving a fractional equation. Now, if you can factor any of the denominators, you want to do that first in order to start. And you could see right here, this denominator is going to factor to give us x times x minus 2. Okay, all I did was factor out the greatest common factor. Okay, so I rewrote this to give myself a little more room, and when I rewrote this first denominator in factored form, because it makes it a lot easier to see what our common denominator should be. See how this has an x and an x minus 2? Well, this has the x, but it's missing the x minus 2, so let's put it there. But remember, if we put it in the denominator, we also have to put it up here in the numerator. And this has the x minus 2, but it's missing the x that the other denominators have, so let's just put it there. So if I put it on the bottom, I have to also put it on the top. And now that all our denominators say the same thing, right, we can just basically disregard them, cross them off, and we're going to solve what we're left with in our numerators. So I'm just rewriting what I see above. Actually, this is going to be a pretty short equation to solve. Okay, so I literally just brought everything down. All right, so let's see. That's going to leave us with 10 plus, and when I distribute the 4, I'll get 4x minus 8, and then equals 5x. Okay, so I'm going to move all my x's to one side of the equation, since these are right x to the first. It's a first degree equation. So I'm just going to subtract 4x from both sides of the equation. So these cancel, and on the right side I'm left 5x minus 4x, it's just 1x. So when I combine my like terms over here, right, 10 minus 8 is 2. So I get x equals 2. All right, now, if we look at this, x equals 2, right? I see that in choice 3. But let's think about this. If I were to substitute 2 into this original denominator, isn't 2 minus 2 0? And we can't have a 0 in the denominator of a fraction. That would make it undefined. So I actually have to cross this answer off. That is what we call an extraneous root. Okay, I basically solved the equation correctly, but because that root makes our fraction undefined, we can't use it. So look at this, we have no solution. So choice 4, see those empty curly brackets? That means no solution. Okay, we have an empty solution set, so choice 4 is our answer.